Hello, welcome to Remediation lesson number 4 for measurement, which is the final lesson for the measurement category. The objective is students will be able to determine the measurement of one interior angle of a polygon using the formula provided with 100% accuracy. Let's look at the definition of a polygon. A polygon is a number of coplanar line segments, each connected end to end to form a closed shape. So in case that's a little confusing, I put some pictures up here of what represents a polygon and what does not. The first part that you can see right now, these are all shapes that represent a polygon. They are all connected end to end, they form a closed shape, and they are coplanar line segments. So you want to make sure that all three of those characteristics are included or form a shape. The next four examples are examples of things that are not polygons. The last example here, this shape here has a kind of a curved edge that does not have a line segment. So in other words, anything that's curved is not categorized or classified as a line segment. The previous three are not closed shapes. So you want to make sure that the definition fits for something to be a polygon. Okay, I want to show you the formula first that we are going to use to find interior angle measures of polygons. Now this formula is also on your formula sheet and it's also in the packet that you have. So the sum of the interior angles of a polygon is given by the formula. The sum of the angle measures is equal to, so here's the actual formula, 180, and then in parentheses, n minus 2. N represents the number of sides of the figure. Now, for the foresight and in this lesson, we are going to focus just on triangles because that's what you'll see on your foresight exam. So n is always going to be 3. As you can see from the definition of the formula, though, n could be 3 to 8-sided figure. So if the sides change, if it's not 3, you'll just substitute a different value in for n, which is fine. And you will do this a lot in geometry if you have not already taken geometry. Okay, so let's look at some examples. Okay, the first example, what is the measure in degrees of the smallest angle in the triangle above? So to find the total degree or the degree of the smallest angle, which is 5x, the first thing that we need to do is solve for x. So we are going to use the formula that we just mentioned. So sum of the angle measurements, I'm just going to put angle measurements, which is equal to 180 degrees, and then in parentheses, n minus 2. Now, for the sum of the angle measurements, when you are given a triangle, you know that there's 180 degrees total for the interior angles of a triangle. And again, if you don't remember that, these are all interior angles. Okay, they're all inside the polygon. So what we need to do for the sum of them is add 5x plus 6x plus 7x, which we get 18x. You should remember from algebra and or pre-algebra, when you add, you can only add like terms. These are all like terms, so you can add all of the terms together. Don't add the x's, you just leave the x alone. Okay, that's just for multiplying that you would put an exponent there. So the sum of the interior angle measurements is equal to 18x. You are going to set that equal to 180. In parentheses, we know this n represents the number of sides. Well, you know in a triangle, there's 3 sides. So we have 3 minus 2. So I'm going to rewrite that as 18x, excuse me, is equal to 180 times 1, because in order of operations, you want to take care of grouping symbols first, which is 3 minus 2, which is 1. So we end up with 18x is equal to 180, because 180 times 1 is 180. So you are now down to a one-step equation. You will divide both sides by 18 to get x by itself. So 18 divided by 18 is 1. So we end up with x by itself on the left-hand side. 180 divided by 18 is 10. So we know that x is 10, so that's x, but we have not answered the question yet. The question is, what is the measure in degrees of the smallest angle in the triangle above? So what you'll do is take your x value, go back to the smallest angle, which is 5x. You will substitute the 10 in for x. So we end up with 5 times 10, which is 50 degrees. This is your answer. That represents the smallest angle in the triangle above, and that is the measurement in degree of the smallest angle. So again, your answer is 50 degrees for this problem. Okay, let's go over 2 more examples like this. Hopefully this is making sense. Okay, example 2, same type of question, but now it says, what is the measure in degree of the largest angle in the triangle? So for this one, we know that the largest angle is 10x. So we're going to use the formula again, sum of angle measures. I'm just going to put m this time. Sum of the angle measures, or the interior angle measures, is equal to 180 times n minus 2. So if we look at our triangle here, we have 10x plus 6x plus 2x, which is 18x, which is equal to 180 times n minus 2. Remember, n represents 1, 2, 3, not the angles, but in other words, how many sides there are. 1 side, 2 sides, 3 sides in the triangle. So n represents the number of sides, and what I circled here in green, that was the sum of the interior angles. So we have 18x is equal to 180 times 3 minus 2. So we end up with 18x is equal to 180 times 1. Anything times 1 is itself. So we have 18x is equal to 180. Remember, we're trying to find the largest angle measure, not just x, but we need to find x first. So divide both sides by 18. We have x equals 180 divided by 18. So again, we get 10. Now, that's not our answer. We want to take this x value. We're going to substitute it in for the largest angle in the triangle, which is 10x. So we are going to use the 10x. We are plugging 10 in for x. 10 times 10 is 100. So we end up with 100 degrees, which is the largest angle measure in the triangle for the interior angles. So the answer for this problem would be 100 degrees. Okay, one more example. Okay, example 3 says, what is the measure in degrees of the smallest angle in the triangle above? So we know that the smallest angle in the triangle above is 3x. Okay, so using our formula, we'll get to that eventually, but if you remember from the formula sheet and from the formula we just explained, the left-hand side of the formula has the sum of the interior angle measurements. So we're going to add 7x plus 8x plus 3x, and again we get 18x, which is equal to 180 times n minus 2. Okay, and n is represented by how many sides the figure or the polygon has. Now there's 1, 2, 3. So of course a triangle is going to have 3 sides. So we are going to substitute or plug in 3 for n. So again, this is just like the other problems. Next thing you want to do is subtract what's inside parentheses. 3 minus 2 is 1. We end up with 18x is equal to 180. We want to get x by itself. So we will divide both sides by 18. We get x is 10. Now, this is not the answer. The question asks us to find the degree measurement of the smallest angle in this triangle. So you're going to take, and we are going to take what we got for x, which was 10. We are going to plug 10 or substitute 10 in for x in the smallest, or for the smallest angle measurement. So we end up getting 30 degrees for the solution for this triangle. So this ends lesson 4 in the measurement category, and that is the end of the measurement category. Thank you.